It all started with a challenge when our wind business head went to the American Wind Energy Association conference and came back to us with a poser. So the question was whether it is possible to create a more intelligent wind turbine that uses the data, adjusts, predicts and controls the amount of energy it puts onto the grid, and hence creating a more grid-friendly turbine.
We only had a couple of hours to decide if we were ready to take on this challenge or not. What do you think? Of course, we jumped at it.
We faced a lot of challenges while working on the program, but what kept us going on was the thought that the technology that we are developing is going to make a big impact to the energy situation of the world.
We started working on the prototype. Sleepless nights, endless coffees. We were in constant collaboration with our US teams all together. It was a brilliant team effort.
Today, novel storage integrated turbines has got the industry buzzing, a challenge in innovation and 12 months to deliver. The product has been commercially launched and is one of our many success stories.
Our operation has become a little bit more complex because of a simple reason, that's dirt. Our compressor blades need to remain smooth to stay efficient, but it does not happen that way, and that's the crux of our problem.
Not all non-stick surfaces like this are known to be corrosion resistant, but not all corrosion resistant materials are known for its non-stick properties. So the challenge is, how do you get the best of the two worlds?
The problem was serious and we had to find a solution to this. A number of possible solutions that came out of brainstorming and discussion, but yet the problem of bringing the surface back to its original finish remained.
So that was when the power and water engineering team reached out to global research team for help. The best of JE engineers from either side of Atlantic got together.
Smooth blade surface, superior efficiency, high technology, clean environment. So all the elements were there. All that we needed was spark of an idea.
We had to test more than a dozen coatings and architectures. Amongst them, we actually had a device that could polish the blade down to a mirror surface finish all within 2 minutes flat. What was very interesting was that the finished blade actually had very good corrosion resistance, which was a unique aspect of that process. What is also very interesting about that process was that we don't have to take the blades out of the rotor. This is a very novel concept. We actually had more than 6 patents filed from this program, and we had a know-how which we did not have before.
The business always brings us exciting challenges. This time it was developing 100 locomotives for Indonesian railways. Our customer wanted a lightweight locomotive that is highly reliable, fuel efficient and with advanced control system.
Normal locomotives have 30-ton axle load in the US and 22.5 ton in the Commonwealth countries. The challenge thrown at us was to design a locomotive for 15-ton axle load.
The key challenge was to design and package the slim locomotive adhering to the strict emission norms.
We design and develop a highly efficient and environment-friendly diesel engine, AC to DC propulsion system using various simulation and modeling techniques. For this, we utilize 3D modeling, combustion modeling, and system simulation techniques. We also developed human-machine interface, which provides complete visibility to railway operator in order to view all the subsystems for monitoring and diagnostics purposes.
After 170,000 hours of intense engineering development, this marvel was put to the market, and the results are there to see. This locomotive has demonstrated the longest and heaviest train, weighing 1,700 tons, to be hauled without a sweat.
160 plus engineers, passion for technology. It's great to know that this result has redefined the Southeast Asian market.
Today we remember it as designed in India, made in USA and delivered in Indonesia. And our next trip is South Africa.
I moved back to India after about 12 years of being in the US. And when I first went out to the market, to see what kind of products we could make to save the lives of newborn babies. I quickly realized that we had to unlearn and let go of a lot of assumptions we had in the US. So we knew we had to make products that were tough to withstand the harshest conditions that rural India had to throw at us. And yet at the same time, we had to make products that were affordable, yet clinically provide the level of care that every baby deserves in India.
Cost is the biggest challenge we have while designing a product because our products goes into emerging market. And how we do so is by doing disruptive innovation and doing the entire product starting from scratch here in our facility.
LED phototherapy is another innovation that just lit up lives of many little ones. 60% of the newborn babies go through this jaundice kind of a condition, and which is nearly treated globally by CFL kind of a tube lights, which needs to be changed every 6 months. When we started a new product development in GE, we introduced LED technology, which treats the same condition, I think 28% faster. At the same time, I think it reduces the operating cost by around 60%. And I think the happy news is that we have saved more than 200,000 lives globally.
Suddenly, a new world of opportunities has been born and a chance to touch so many million tiny lives. What could be more heartwarming than that?